Okay, good morning, students. This is a class of geotechnical engineering. Today we'll start a new chapter. You can say new module. So the second module, that is permeability of soil. Fine. So if you have any doubt up to the last class, you just you can bring that particular question in the next coming classes. Okay. So we can also go for revision if you want for the last module. Okay. So you don't need to worry. Okay, so yeah, we're going to proceed to the next model, that is permeability of soil today. Fine. So first I'll just share my sharing now. Okay, before that I just want to mention you, okay, right now I don't have that attendance sheet right now. Okay, so anyone if CR is present here, please note the attendance, or you can just take the screenshot of the attendance, okay, and send me in WhatsApp. Is it possible for you? Please respond in chat box. Anyone can give the attendance for today's this class? Any respond? I can't record the attendance right now, okay, because I'm in college right now, so I don't have the attendance sheet at present. So anyone, please give me the screenshot of the participation list, or just give me attendance in a white paper. Is it possible? Okay, so we'll just start my sharing now. Wait for some time. Okay, I guess my screen is visible, right? My screen is visible. Okay. So yeah, so basically we are starting that new model, that is permeability of soil. I think you can see it is the name of the topic, the name of the model, that is permeability of soil. Fine. And here Darcy's law is given here. So it's a very important law that you need to understand, related to the flow of water through soil. Okay. So now here you have to understand what do you mean by permeability. Okay, I think yet a basic definition is not given here. Yeah, you can also find out. Yeah, it is given here. Okay. So anyway, I just want to share that the basic definition of permeability. So permeability is just a kind of a property of soil. Okay. Permeability is a property of soil which allow it which allow the passage of water or any fluid which allow passage of water or any fluid through its interconnecting voids. Okay, I'm again repeating. Permeability is defined as a property of a particular soil which allows or which permit the passage of water or any fluid through interconnecting voids in a soil mass. Okay, it's a very simple definition. Permeability is related to the passage of water or flow of water through soil. Okay, if you consider a partially saturated soil or saturated soil, the voids are uh, in a voids water is present. Okay, partially or fully. Okay, and it is not stationary. Almost it is not stationary water, since there is always a gradient. Gradient means I think you know how water flows. Okay, just take a example of a plan table. Suppose in which table you are sitting right now. You are, studying right now, okay, or decks, okay, in a particular decks which is completely level with horizontal, if you by mistake, suppose if you by mistake you pour some water in a particular table, what will happen? Maybe if your table is completely horizontal uh, with a ground surface, or you can say if the table is completely leveled, then water will stay there only. Okay. Now if you try to tilt your table in one direction, any direction, okay, then what will happen? The water will flow in that particular direction. So what is this happening? Because of the difference in the gradient. Okay, I'll tell you one thing. Wait, let me take one pen. Yeah, suppose this is except color. Like change the color. Yeah, suppose this is a point. Okay, suppose this is a point A. Okay, now suppose this is a point B. Okay, now suppose point C. Okay, now if suppose water is flowing in this direction, suppose water is flowing direction, so if you want to find out whether the water is flowing from A to B or not, suppose water is at just at this point A, not is flowing in this direction, suppose at this point only, suppose water is at this point only, so it is very difficult for water to travel from A to B since A and B is almost in a similar or same level. Okay, now since A and C is in different level from the ground, suppose this is a ground level, from ground the height of A is this much and height of C is this much, so automatically you can say there is a head difference in head between A and C. This is the head difference, and because of this head difference water may flow from A to C. Okay, fine. And this is because of the hydraulic gradient. I think about the gradient you already heard this term in hydraulics. Okay, so it is similar like that. Water is flowing from A to C because of your hydraulic gradient. And how can you find out hydraulic gradient? Denoted by small I, denoted by small I, which is equal to H by L. Okay, H is what? The head difference between these 2 points. Okay, and what is L? It is the horizontal distance between A and C. This is L, the distance between A and C. The horizontal distance between A and C is denoted by L, and the vertical distance, or vertical difference, or you can say the pressure difference or head difference. Okay, someone is waiting. Wait. This pressure difference or head difference is denoted by this H, and the ratio of H by L is given as I. I means hydraulic gradient. Okay, this is very simple and basic things. So regarding that, this all these things are given here. In usually water flow is occurs due to three heads. Okay, pressure head, elevation head, okay, and velocity head. Okay, all these things are, I think you have already got in hydraulics. Similar thing. Okay, fine. Okay, now you can see here it's given here total head consists of three components: elevation head, pressure head, and velocity head. Okay, as surface velocity in soil is normally low, that means the speed of the flow or velocity of the flow is very slow or very small, the velocity head is ignored. Okay, and the total head becomes equal to the piezometric head. I think about piezometric head also you already got these things. Piezometric head is what? It measured the pressure head, isn't it? Okay, now based on or regarding or related to the passage of water or flow of water through soil, Darcy has given one concept. Okay, Darcy is a name of a particular scientist, you can say. Okay, that's why the law given by him, it is known as Darcy's law. Okay, so what Darcy's law all about? Darcy's law state that uh, I'll just simplify the particular this relation, this definition. Darcy's law state that the discharge through a particular soil or rate of flow through a particular soil is directly proportional directly proportional to the hydraulic gradient and directly proportional to the cross-sectional area of the soil mass. Okay, Darcy's law state that I think here from here also you can see. Suppose this is a soil mass. Okay, this rectangular structure. Okay, this is three-dimensional drawing is represented by a soil mass. Okay, and this soil mass having length of L, fine, and cross-sectional area. Suppose this cross-sectional area represents by this A. Okay, capital A represented by this cross-sectional area. Fine, and water is flowing from this direction to this direction. How can we say? Because of identifying these two piezometer. So I think you already know about piezometer. These suppose these two piezometers are inserted at entry point and exit point. Okay. Now here you can see the water pressure is so high here. So water is rises up to this level. Okay. And when the water flowing out at this zone or at this point, water's level is up to this level. That means water pressure. Okay. So from this diagram, you can say there is a pressure difference or there is a head difference. How much? Delta H. Okay, the difference between this point and this point represented by delta H. Here also you can see delta H what? Difference in total head. Okay, so here you can see delta H is a difference in total head. Okay, what is L? L is the length of the soil mass. A is the cross-sectional area. Fine. Now, as per Darcy's law, is given as what? The discharge or rate of flow. Rate of flow means what? The water flowing through the soil per unit time. Here you can see the rate of flow denoted by small q. Rate of flow, that means meter cube per second, right? It is denoted. The unit of small q is meter cube per second. Meter cube represented by volume, isn't it? Or you can say volume is represented by meter cube and second time is represented by second. Okay, so unit of small q is meter cube per second. Okay, so the rate of flow, that is q, through cross sectional area capital A of the soil mass, and Darcy's law states that the discharge or rate of flow is proportional to the cross sectional area of the soil mass and hydraulic gradient. Okay, from that particular statement we can find this relation. Okay, so here if you concentrate here, this small q represents what? Discharge or rate of flow through soil mass. Okay, this v represents what? That what your velocity, isn't it? Velocity of flow. Okay, and A represents what? Your cross-sectional area. Okay, simply you just, as per Darcy's law, we can, I'll just give you one simple definition. Wait. Yeah. So as per Darcy's law, given as this discharge. Wait. That means I'll just want to draw one Q. Okay, small Q. Try. Let me try. Suppose this is a Q. Okay, it is not clear, but anyway, suppose this is a rate of flow. It is given as it is proportional to the cross-sectional area of the soil, also proportional to the hydraulic gradient. Fine. It is as per Darcy's law is given as discharge or rate of flow is proportional to the cross-sectional area of the soil, also with the hydraulic gradient. Okay, and also you have to consider remember here, this rate of discharge is proportional to the cross sectional area of the soil perpendicular to the flow. Okay, that means if water is flowing in this direction, you should not consider this area. You should consider this area, because this area is perpendicular this flow, and this cross sectional area is along the flow. Okay, because a particular soil, if you consider this rectangular shape of soil, there's a different kind of cross sectional area, isn't it? This is also one cross sectional area, this one also, isn't it? So what cross sectional area you have to take? That means this discharge, that means this discharge is proportional to this area or cross sectional area which is perpendicular to the flow direction. Fine, it is clear. Now we can join all this together. That means we can write down Q is proportional to that I, sorry, A, isn't it? We can also write rate of flow is proportional to I into A, where I is what? Hydraulic gradient, A is what? Cross sectional area perpendicular to the flow, isn't it? Clear? Now, if we replace this proportional symbol with a constant term or with a equal symbol, how do you can say, what you can write mathematically? Q equal, suppose I replace this proportional symbol by this equal symbol, so we can write Q equal with a one constant, that is K I A. Okay, so we can write Q is equal to K I A. Okay, so this is the equation proposed by Darcy. Q is equal to KIA. Okay, Q, where Q is what? Discharge per unit time or rate of flow or rate of discharge, whatever you say. K is what? Okay, we'll discuss about K later on. First, I is what? Hydraulic gradient, and hydraulic gradient can also be written as what? I is equal to H by L, isn't it? So in this case, your H is represented by delta H. So delta H by L. Here you can see I is equal to delta H by L, or simply H by L. Or I is what? Hydraulic gradient. A is what? Cross-sectional area perpendicular to the flow. And A is a constant of proportionality. And the name of K is what? And it is known as coefficient of permeability. It's very important. Here you can see K is what? Permeability of soil is given as, but technically it is known as coefficient of permeability. Clear hai? Fine. I don't think there's so confusion here. It's very simple to understand. The main equation you can say Q is equal to KIA. Fine. This is the Darcy's law. Fine. Yeah. Now, whenever you say velocity, whenever say velocity of flow, we can define the velocity of flow of water through soil by two ways. Okay, there are two type of velocity of flow. One is your theoretical velocity or theoretical discharge. Another one is your actual discharge related to the actual velocity of flow or seepage velocity of flow. Fine. Now, what is the difference between uh, your actual discharge or actual velocity or theoretical velocity? Okay. Now, whenever I say theoretical velocity, theoretical means it's not practical or not actually occurring. Theoretical velocity is that particular velocity related to that theoretical discharge where the cross sectional area is the total cross sectional area of the soil mass is considered. Okay, since we already discussed about water is flowing in this direction and water is flowing in this direction and total cross sectional area is considered here. And if you find out the velocity of flow using the Darcy's law, how can you find out? V is equal to Q by A. It is very basic definition of discharge. Q is equal to VA. Okay, I think you know this term. So we can find out discharge, or sorry, you can find out velocity of flow. Okay, or you can say that theoretical velocity of flow V is equal to Q by A, where Q is what? The discharge or rate of discharge or rate of flow as per Darcy's law, and A is what? A is your total cross sectional area, not total actually, cross sectional area of the soil mass perpendicular to the flow. Okay, and this velocity is actually what? This is your theoretical velocity. Okay, this is not actual velocity. Why I have said this is not actual velocity? Because as you know, this is related to the flow of water. Fine. This permeability is related to the flow of water, and water is flowing through the voids only, not through the whole area. If you consider the three-phase diagram, a particular soil mass consider what? Soil solid, water, and maybe air, isn't it? Now, since water coming or go through or passes through only through the voids, so we can only, if we can only take the volume of or area of the voids only, if you put in place of total this A, in place of this, if we put area of voids, if you consider only area of voids, then that particular discharge will be actual discharge, or you can say CPS discharge, actual discharge, yeah, you can say, or the velocity of flow that can be find out by dividing the rate of discharge by the cross sectional area of the voids. Okay, not cross sectional area of the soil mass, cross sectional area of the voids perpendicular to the flow. Then that velocity will be known as actual velocity or CPS velocity. Okay, and this actual velocity is always greater than your theoretical velocity, and theoretical velocity is also known as superficial velocity. Fine, theoretical velocity also known as superficial velocity. Here you can see the flow velocity is known as, the flow velocity means that theoretical velocity. Okay, the flow velocity is also known as Darcian velocity as given by the Darcy's law. Okay, Darcian velocity or superficial velocity. It is different from actual velocity inside the soil pores, which is known as the seepage velocity, denoted by small vs, s for seepage. Okay, and we can also define the relation between actual velocity and seepage velocity. Here you can see seepage velocity can be defined by your theoretical velocity divided by your porosity. Okay, you have to remember this. Okay, fine. It is clear till now. So this is all about today class. Okay, so next class we'll discuss about some laboratory test for determination of permeability of soil. Fine. So is there any doubt till now regarding Darcy's law of flow of water? If you don't have any doubt, then I'll just close my slide. Okay, I have got that attendance. Okay, screenshot, got it. Okay, any doubt till now? नहीं है doubt. Anything? Wait. एक second. ओके, अगर डाउट नहीं है तो आई जस्ट क्लोज माय रिकॉर्डिंग। ओके, यूनिवर्सिटी कब खुलेगा? हम लोग तो अभी कॉलेज में ही है। फॉर योर स्टूडेंट्स आई डोंट नो, आई थिंक द इन्फॉर्मेशन विल कम as per it will follow the as per government norm. Okay, so I can't tell you now whether when the physical class will continue. So till then we'll just continue with that online class only. So we'll decide about that later on. But anyway, related to class, anything to ask? No. So I'll just stop my recording now.